Hello everyone. Our task is a problem-based learning module centered on accident reconstruction using physics. We are investigating a severe multi-vehicle right-angle collision that occurred in Alamusta, resulting in a fatality. Inspector Hakim needs to scientifically determine responsibility. The central question is, did the driver of car A run a red light or was the driver of car B driving too fast? This is a case where static evidence must be converted into dynamic proof. We are relying on fundamental principles, the conservation of momentum, and the work energy principle. Key data includes car A, which weighed 4,000 kilograms and skidded 7 meters, and car B, which weighed 3,000 kilograms. Our critical tool is the skid to stop formula using the formula that you see right now. By applying this alongside kinematic equations, we can calculate the precise pre-collision velocities of the vehicles. This physics driven analysis will transform the scene evidence into crucial quantitative data, allowing us to accurately identify the responsible party.
Hi, I'm Benedict, and today I'll be sharing our abstract for our PBL report. First of all, this report presents a detailed physics-based investigation of a multi-vehicle collision involving two cars and a motorcycle at an urban intersection. Using the integrated online project problem-based learning PBL framework, the analysis integrates key concepts of mechanics, dynamics, and energy conservation to determine the cause of the accident. The main character of the problem, which is Inspector Kim, is involved in an investigation that involves identifying critical questions related to the vehicle speeds, direction, point of impact, and the physical forces during the collision. Measurements such as a skid mark lengths, collision angles, and resting positions of the vehicles were recorded to support a systematic reconstruction of events. By applying Newton's law of motion, the work energy principle, and the conservation of momentum, the velocities and kinetic energies of each vehicle were calculated prior to the collision. The coefficient of friction for both the road and grass surfaces were determined, which allowed accurate estimation of braking distances and impact forces. Findings revealed that car A, with a mass of 4,000 kg and higher velocity, generated the greatest impact of force and kinetic energy, confirming it as the primary cause of the collision. Environmental conditions such as sunny weather, dry road, and high frictions were found to have minimal influence, thus emphasizing driver error as the dominant factor. In conclusion, the reconstruction established that car A likely ran a red light and struck car B and the motorcycle at a right angle. The results not only demonstrate the application of fundamental physics law in real-world scenarios, but also highlight the importance of frictional analysis and kinematic reconstruction in forensic accidents investigation.
Hi everyone, now I will talk about how physics help us understand the bicycle collision. When an accident happens, we use physics to study how the bicycle moved, what force were involved, and how energy was transferred during the crash. First, Newton's law of motion. According to Silver and Jewett, Newton's law of motion explains how force affects motion. The first law says the car keeps moving or stays still unless something causes it to change. The third law tells us that when two cars collide, each one pushes one another with equal force. This law helps the investigator understand how motion changes during a crash. Second is conservation of momentum. The conservation of momentum principle means that the total momentum before and after a collision stays the same if no outside force acts. According to Halliday, Resnick, and Walker, this helps experts find the speed and direction of bicycles before the impact. In two cars crash, momentum in different directions is studied to find which bicycle caused the greater force. Third, work energy principle. The work energy principle connects force, distance, and energy. During a crash, moving energy, which is kinetic energy, turns into heat, sound, and damage to the car. Kian Pillai explained the energy is lost because of friction and deformation. Next is impulse and momentum. The impulse momentum theory shows how force and time are related. According to Hebler, impulse equals the force multiplied by the time it acts. A short impact time means a high force, which explains why some crash cause more damage and injury. Other than that, there is also coefficient of friction. The coefficient of friction tells how slippery a surface is. Branch state that it depends on the road, tire condition, and weather. High friction help cars to stop quickly, while low friction can cause skidding. Kinematics. Kinematics is the study of motion. How far, how fast, and how long. Young Friedman said these calculations help find bicycle speed and movement before and after crash. This helped investigators rebuild what really happened.
Hello everyone, in this video I will explain the methodology used in this accident reconstruction analysis. First, we begin by establishing the key physical parameters and research question. We measure the final position of all vehicles and the motorcycle riders, record the skid mark lengths, vehicle masses, and noted environmental conditions such as dry road and clear weather. Visible damage patterns were also analyzed to estimate the direction and strength of the impact force. Next, using the collected data, we apply the work energy theorem to calculate the post-impact velocity. The kinetic energy lost by the vehicle was equated to the work done by friction over the skid distance. This allows us to find the velocity of both the motorcycle and car A. Then, using the law of conservation of linear momentum, we determine the pre-collision velocity of both cars by resolving momentum into x and y components. Since both vehicles move in the same direction after the crash, the collision was treated as inelastic. Finally, we compare the calculated speeds to legal limits and analyze the impact forces to determine which driver violated traffic laws, whether car A ran the red light or car B was speeding.
And now let's move on to the second part, which is the discussion. For part 1 of our project, our focus was on the first stage of the accident investigation, collecting data needed to understand how the collision happened. Inspector Hakim began by observing the scene and identifying key physical evidence such as the position of each vehicle, the length of skid marks, and the direction of travel before and after impact. He also needed to check the condition of the road surface, any slope, and the weather, because these factors can affect friction and braking distance. From a physics point of view, principles like Newton's law of motion, the conservation of momentum, and the work energy principle are very important here. They help explain how forces acted on the vehicles, how kinetic energy was converted into deformation and motion, and how the cars and motorcycle behaved during impact. And now, let's move on to the second part of the discussion. In part 2, we analyze the evidence to understand what actually happened during the collision and who was likely responsible. From the data, it was concluded that the driver of car A probably died because his car had severe front left damage and clear skid marks, which suggests sudden braking and a strong impact. Meanwhile, car B showed no skid marks, meaning it was likely moving slower or had less time to react. The motorcycle rider was seriously injured, but probably survived, since the evidence showed that he rolled several times before stopping, meaning the energy was spread out instead of absorbed all at once. Weather and road conditions were ruled out as causes because the day was sunny, dry, and clear, which means good visibility and normal friction. Therefore, the main factor behind the accident was human error, most likely because car A ran the red light and entered the intersection too fast.
So next, we're moving on to the discussion for the third part of the PBL. So in this phase, we actually need to do some calculations to find out who is responsible for the crash. So as it states here, in the third and final phase, we perform an actual calculations to estimate velocities, forces, energies, and ultimately responsibility. So first off, we have our assumptions, which are the coefficient of friction of the road and the coefficient of friction of the grass, which are 0.6 and 0.4 respectively. So for this, we use the formula V equals to square root 2 micro gs, where V is velocity, micro is the coefficient of friction for either the road or grass. G is the gravitational acceleration, while S is the displacement. To calculate pre-impact velocities of each vehicle, So after we input the necessary information into the formula, we found out that car A has the highest velocity out of the three vehicles, which is 9.07 meter per second. The motorcycle had a velocity of 7.67 meters per second, while for car B, it is estimated that the speed is around 3.14 meters per second. So, taking a look at these results, we find out that car A is actually moving the fastest, thus carrying the greatest kinetic energy before impact. This also shows that car A is highly likely to be the one that is responsible for the crash.
Based on the overall analysis of physical evidence and calculation, it can be concluded that car A is responsible for the accident. The 7-meter skid mark observed at the scene indicates that car A was moving at a higher speed and applied the brakes only shortly before the collision. Using the work energy principle and the skid mark to stop formula, the pre-impact velocity for car A was determined to be approximately 9.07 meter per second, that is 32.7 km per hour, while car B estimate velocity was around 3.14 meter per second, that is 11.3 km per hour. The result from the conservation of momentum calculation also revealed that car A had a greater momentum than car B. Its larger mass and velocity producing a stronger impact force that pushed car B forward after the collision. The road surface was dry and the coefficient of friction was relatively high, suggesting that weather and road conditions were not contributing factors to the accident. Next, the main cause was human error by the driver of car A, who failed to stop in time and entered the intersection at an unsafe speed. In conclusion, the PBL investigation successfully applied the principle of momentum, energy, and friction to analyze a real-life collision scenario. The findings confirm that car A's driver was at fault for the accident to excessive speed and delay braking, while car B and the motorcycle were secondary victims in the chain of impact. This project effectively demonstrated how physics concept can be used to determine accident responsibility through data interpretation and evidence-based reasoning.